Hello guys, welcome to the workbook. The question that we are going to solve now says determine the area of the region bounded by the curve y is equal to x square plus 2, another curve y is equal to sine of x, the lines x is equal to minus 1 and x is equal to 2. So let's first understand the question and then we can proceed to the solution. We are being given four different equations. Y is equal to x square plus 2, y is equal to sine of x is equal to minus 1, x is equal to 2. Let us plot these first two equations on the coordinate system. As we have plotted the two curves, now we can clearly show the area between these two curves. So the shaded portion or the yellow colored portion which will appear now is nothing but the area between the two curves. Now the yellow colored region that appears between the two curves is the area between these two curves. We will next plot the two lines x is equal to minus 1 and x is equal to 2 over this shaded portion and over the two curves, and then find out what is the exact intersection area between the four curves altogether. So as mentioned, the green color line represents x is equal to minus 1, that is this line, and the violet color line represents x is equal to 2, that is this line. Now if we observe closely, we can see that there is a particular area, the shaded portion that I am showing is the area that is falling in between these four curves. So this area is the area we need to find as the answer to this question. So this shaded portion is the area between the four curves mentioned in the question. Here and the small part too. Why we are not considering this outer area on the left side and the right side? Because it is beyond the two lines x equal to minus 1 and x is equal to 2. And also why we are not considering this white shaded white portion above and below the two curves? Because this is beyond the red curve. This area is beyond the red curve and this area is below the sine x curve, that is green colored curve. From this graph, we note an important observation. The shaded region here is not a regular figure like a rectangle or a square or a circle, but it's an irregular figure bounded by the two curves and the two lines. So it's obvious that to find out the area of this shaded portion, we will have to use integration method. For using the integration method, first we will have to decide the limits of the shaded region. So moving on to the solution, we know that first step of the solution will be deciding the limits. So first step of the solution is limits of integration. Limits of integration. So let us decide the limits first in the x direction. In the x direction on the graph we can clearly see that on left side there is a constant number minus 1 which is the limit of the area, a straight line, and on the right side this straight line is at x is equal to 2. So our limits will be x1 is equal to minus 1 and x2 is equal to 2. Now in the y direction, in the x direction is minus 1 and 2. In the y direction, if you observe, there is there is not a constant number which is representing the y limit, but there is a curve. Okay, so this curve, the upward curve, that is the above curve, that is a red colored curve, is our y limit. So we can write y1 is equal to x square plus 2. And similarly, on the below side, the green curve is our limit that is bounding our area, which is y equal to sine x. So we can write y2 is equal to sine of x. So the shaded area that we need to find is varying in between y1 and y2 and x1 and x2. Now moving on to the step 2 of our solution, that is finding out how the area is calculated. So we know that a general formula to calculate this area of the shaded portion is equal to integration x1 to x2, because obviously x1 and x2 are constant numbers. So we are integrating between these two constant numbers, y1 minus y2 with respect to x, because x is our independent variable. Now that we are ready with the limits in both x and y direction, let us move to the solution, step 2. So, step 2 of the solution is to integrate and find out the area. So, area of the shaded portion corresponding to x1, x2 we have minus 1 to 2, and corresponding to y1 we have x square plus 2 minus corresponding to y2 we have sine of x dx. Now the next step is integrating these terms. So it's equal to integration of x square is x cube by 3. Integration of 2 is 2x, because we are integrating with respect to x, minus integration of sine x is minus cos x, and the limits are minus 1 to 2. Now moving further, we can put these limits in the integrated terms. In the next step, in place of x we can write 2 cube by 3 plus 2 into 2, minus into minus becomes plus cos of 2. Now the lower limit is minus 1, so let's put the lower limit, minus of minus 1 whole cube by 3, minus 1 in place of x, so plus 2 into minus 1, and minus minus becomes plus cos of minus 1. Let's evaluate these terms in the next step. So it's equal to 2 cube is 8 divided by 3 plus 2 into 2 is 4 plus cos of 2 minus, now these terms are minus 1 cube is minus 1 by 3, minus into minus becomes plus, so we can write plus 1 by 3. In the second term, 2 into minus 1 becomes minus 2. Again, minus 2 into minus is plus 2. In the third term, cos of minus 1 is positive, so into minus becomes minus cos of minus 1. Let's now simplify these terms. What we get is 8 by 3 plus 1 by 3 becomes 9 by 3. 9 by 3 gives 3. 3 plus 4 gives 7. And 7 plus 2 gives 9. So 9 plus cos of. Now here, what is the unit of this angle? The unit of this angle is definitely radian, because as we know 2 is nothing but the x limit and it's a length unit. So we'll have to write here 2 radian. It's not degree, it's radian. Please note that it's radian. And here in the last term, we know that cos is an even function. So cos of minus theta is equal to cos theta, because cos is an even function. So this last terms then becomes minus of cos minus 1, that is minus theta, is nothing but cos theta. So this will be cos of 1. This is again radian. Writing the final answer, area of the shaded portion is equal to 9 plus cos 2 radian minus cos 1 radian. I hope you must have understood the answer. Thank you so much.